process of research and chemistry. Now, if say for example you want to research something, say for example if you're experimenting on something and you get certain data, and that thing you have just done now is called research. Okay, so research means getting data out of proper scientific experiments. Okay, so doing research actually involves different certain type of procedure. You have to follow certain steps, certain rules in order to conduct a scientific research actually. Say for example, we know that there are different types of chemical reaction, and if a chemical reaction is happening and that is generating heat, then that chemical reaction is called exothermic chemical reaction. On the other hand, if a chemical reaction is taking place and the whole environment is or the surrounding area of the chemical reaction is becoming cold, or it's cooling down, or the temperature is dropping, then that chemical reaction is endothermic chemical reaction. So you're probably thinking that what is this endothermic or what is this exothermic? You have actually witnessed this a lot of times in your life. During the winter people burn stacks or woods or whatever they find around themselves, and they burn those things and they gather around the fire. And why do they gather around the fire? In order to warm themselves up. And how they warm themselves up? When the fire is burning those things, it actually generates heat, right? So if the heat is being generated and it's being transferred into the environment, and people surrounding that area is actually taking the heat and warming themselves up, right? So see this procedure here, a chemical reaction is taking place, and this chemical reaction is called exothermic chemical reaction. On the other hand, if you take say for example you take a bottle of milk, or you take or you take a let's say for example you take a frozen food out of your fridge, okay, and you keep it on the table and you keep it for a long amount of time at the at the room temperature, and after a certain amount of time you will see that the ice layer over the product, it has started to melt. Okay, you will see water spreading around. Or another easy example would be ice melting. So we take the ice out of the fridge and we keep it at the room temperature, we keep it somewhere around in the room, and after some time you will see that the ice has entirely converted into liquid. And how is that done? This has been done by absorbing heat from the environment. Okay, so this chemical reaction, ice melting and turning into water, this chemical reaction is called endothermic chemical reaction. Now if you mix ammonium chloride with water, then the water will become, the water will, lose its heat. The temperature will cool down. The temperature will drop. Okay. So on the other hand, if you mix calcium oxide with water, then the container you're mixing or the glass you're mixing, that becomes hot. The temperature rises, which means that when you're mixing ammonium chloride, that's an endothermic chemical reaction. In the endothermic chemical reaction, the surrounding area, it cools down, the temperature drops, okay, it becomes cold. On the other hand, in the exothermic one, the environment becomes warm, the temperature rises. So how am I able to tell all this information? How am I able to identify this is an exothermic chemical reaction, this is an endothermic chemical reaction, and how can I differentiate in between them? I can differentiate in between them with the logics, with the theories, with the datas I have found. Okay, and these things are actually experimented by different scientists, and they actually gave us ideas. They gave us that if a chemical reaction is taking place and the environment is becoming warm, then that's exothermic. If a chemical reaction is taking place, the environment is becoming cold, then that is endothermic reaction. Okay, so that's how I was able to tell, right? And in order to become in order to get a more precise idea, more precise data, we need to do chemical experiments. And these experiments, while doing these experiments, we need to take notes, we need to take data of different times in order to match, and and in order to get the precise result. Okay, so say for example, we want to know that how actually ammonium chloride affects the water. Okay, or what's going to happen if I add more ammonium chloride, and what's going to happen if I add less ammonium chloride to the water. So in order to find that out, what we need to do is we need to take our water and we need to measure the volume of water that we're experimenting on. And obviously we also need to measure the amount of ammonium chloride we're providing it. Okay, so at first we can begin with smaller amounts, then we can go larger amounts. Okay, so we will find differences in between the data that we're going to get. So that's how a chemical experiment is done. A chemical experiment is done by observing, okay, and by changing the different you can say that doing a same experiment for different types of situation, and then we can actually come to a conclusion. If you follow a certain step for once or twice, that won't be enough to give you the enough data or a precise result. Okay, you need to do several tests. This has to go through some several steps in order to get the precise data. So let's see the chain over here. So first of all, we need to select a certain topic. Okay, so topic selection is a must. So let's say that I want to experiment that how ammonium chloride reacts with water. Okay, so my topic is ammonium chloride, a reaction in between ammonium chloride and water. Our topic has been selected, and now what we need to do is we need to gather the ingredients or the equipments that we need in order to do this chemical reaction, and that is we need a beaker in which we're going to put the water. So obviously we're going to take a certain amount of water. Say for example we take 250 milliliter of water. Okay, we take this much of water, and what we're going to do is we're going to measure the initial temperature of the beaker or of the water. Okay, so let's say that we get the initial temperature 20 degrees Celsius. Okay, this is the initial temperature 20 degrees Celsius, and what's going to happen is at first we're going to mix a little amount of ammonium chloride. Say for example, at first we're going to mix 5 grams of ammonium chloride, and then we will see the temperature has dropped, and now after the temperature has dropped, we're going to measure the temperature and we're going to take note. Okay, then after that we're going to add another 5 grams of ammonium chloride to it, which means the solution now has 10 grams of ammonium chloride. Right, now the temperature is going to drop some more, and we're going to take a note of that temperature as well. Next we're going to add some more ammonium chloride. Say for example another 5 grams of ammonium chloride into the solution, and now we're going to see that the solution has 15 grams of ammonium chloride, and the temperature is going to drop some more, even some more. Okay, so we're going to take notes of different temperatures, and if you analyze the temperature, if you analyze the data at the end, you will see that the more ammonium chloride you're adding into the solution, into the water solution, the more the temperature is dropping. Okay, okay, so see. Okay, so our topic selection, acquiring relevant information. So acquiring relevant information is the part where we took the information about how much water we are taking. We have taken 250 milliliters of water, and what was the initial temperature of the water? That was 20 degrees Celsius. So that's a relevant information. These are the relevant information. We can also take other information. Say for example pressure, the pressure which is present in the area where we're doing or conducting the chemical reaction, and we can also measure the humidity and other stuff as well. These are informations that we take before conducting the chemical reaction. Then planning of experiment. Now we can plan the experiment. See that we plan that we're going to be adding little amounts of ammonium chloride, right? We that was our planning, that we're going to do this process in step by step. First we're going to add 5 grams of ammonium chloride, then we're going to add another 5 which means the solution will have now 10 grams of ammonium chloride. Then we thought that we're going to add another 5 grams, which makes the solution having 15 grams of ammonium chloride. Okay, so this is the planning, right? And this planning has to be done before conducting the experiment. Okay, and proper planning is the key of doing a perfect experiment. Okay, and then the experiment is done. The experiment is actually the practical thing. You do actually mix the ammonium chloride with the water, and you do this by step and by steps. And when you're doing this, at the same time you need to do the data collection. Now data collection is something that we do during the experiment, and also we analyze it. Okay. And so, what is the data collection over here? When we're adding 5 grams of ammonium chloride, the temperature is going to drop, right? The temperature is going to drop. Previously, the temperature was 20 degrees Celsius. Now, let's say that after we have added 5 grams of ammonium chloride, the temperature has dropped to 15 degrees Celsius. So we're going to take a note about it. Then we have added another 5 grams of ammonium chloride, right? Which makes the solution containing 10 grams of ammonium chloride. So obviously the temperature is going to drop a bit more, and we're going to take notes of that as well. Afterwards, in the third step, we had added some more ammonium chloride, right? So in total we have added 15 grams of ammonium chloride into the solution, and when the solution contains 15 grams of ammonium chloride, it obviously going to show a significant amount of temperature, right? And we're going to take a note about it as well. And if we analyze, the data pretty, pretty decently, actually, we're going to see that the more ammonium chloride we add, so let me make this clear to you by just writing it. So when we add, let's assume when we add 5 grams of ammonium chloride, the temperature is 15. When we add 10 grams, it's 10 degrees Celsius. When we add 15 grams, the temperature is 5 degrees Celsius, let's say. Okay, so see, the more ammonium chloride you're adding into the solution, the more the temperature is dropping, which means that this, seeing this data, you can analyze that the more ammonium chloride is added, the more it's absorbing the heat from the environment. Okay, so absorbing heat is endothermic reaction, which I have already explained to you. Okay, so over here, endothermic chemical reaction is taking place, and the more you're adding, okay, the more you're adding, the more endothermic it's becoming. Okay, the more it's taking or absorbing the heat from the environment. Okay, and finally we can write the result and resolutions if we want to correct something, or you can actually write a theory out of it, or you can write some final consumptions, or you can write the final, you can say that conclusion. Okay, that you got the result, and you can write your own theory, or you can write your own ideas about it, or your own consumption about it. Okay, assumptions about it. So yeah, that's how you can conduct research in chemistry, by following these steps. So the first procedure is topic selection. You must be very specific about topic selection. Then you need to acquire the relevant information, the informations which are relevant to your experiment, which are, these are the experiment, these are the informations which are taken before conducting the actual experiment. Then we have to plan how we're gonna conduct the experiment. Obviously, there should be several steps. Only doing one step or two step won't be able to get you, or provide you the precise result or the clear result. Okay, then we do the experiment, then we collect the data that we get, that we get out of the experiment, then we analyze the data, then we come to a conclusion, then we get our result and resolutions. Okay, so that's how you can actually research in chemistry and get the perfect result, or get the perfect desired desired thing that you want to achieve throughout doing the experiment.